Today I've got this remote control that I bought. So this is a 433 megahertz remote control. As you can see, it's got one of the ugliest actual physical designs of remote control that I think I've ever seen. So you got the 4 buttons, so presumably there's 4 different signals it can send, and there's a little window here you can slide up to protect the buttons from being pressed, or pull up antenna. Don't know if it's actually going to need that, we'll see. And little thing to attach it to a keychain or something. And also in the kit we've got the receiver. So this looks a bit like something that I covered in a video some time ago. I had a transmitter and a receiver for 433 megahertz, and I remember the receiver looked a bit like this, so I'll link that video up above here if you want to see me experimenting with that one. So I haven't looked for any data for this yet, so I'll have to figure out how to connect this up, and I guess I can put some LEDs on here to show what signal is being received. So I'll plug this into a breadboard and see what we can find out about it. Right, so presumably this needs some kind of battery. And normally these things from China don't contain any batteries these days because of the rules about posting rechargeable batteries through the post, I think. Oh, there we go. So it needs some small type of battery here. I'm not sure what type that is. I'll have to look through my battery drawer and see if I've got anything that fits in there. But you can see it's quite a simple design. There's the 4 buttons, a LED, so an annunciator I suppose to show when you're pressing down one of the buttons. This will be an oscillator to get the 433 megahertz frequency correct. And then there's a mystery chip here. So I noticed on the receiver there is some writing. Yeah, it says PT2272 on there. Oh, and this one says SCT2260. So obviously a matching pair of transmitter receiver. So let's see if I can find a battery first of all, some suitable battery. Otherwise I might have to wire it up to the bench power supply here. I'm not sure what voltage that is. I assume it's going to be 3 volts or something like that, but we'll have to see. Yeah, so let me plug that into a breadboard, find a battery, and we can see if we can start sending and receiving signals. Okay, so I found this battery here. So this came out of a doorbell that had stopped working, and it looks exactly the right size to go in here. And I just had a look in the had a look online for the datasheet for the chip on here for the SCT2260, so that encoding chip can tolerate up to 12 volts. So I think this is exactly the right battery. So let's put it in. Press one of the buttons. There we go. And the LED comes on. So that looks good. So I'll assemble this, I guess. case. It does need the screw to keep it all together. I'll put that back in. Okay, so we've got the right battery. Now I just need to plug this in and see if anything responds when we press the buttons here. So I've wired up the module, the receiver module now. So I've got this strip of LEDs here. So there are 5 connections on the board itself. Let's see if we can see down there. You see there's 4 pins marked D0 to D3, which obviously correspond to the buttons. There's also something marked VT. I didn't know what that was, but I'm assuming it's an output. So I've connected all 5 of those to the first 5 LEDs in this LED array, and I've got some 100 ohm current limiting resistors there, so I don't blow the LEDs up, because I'm not sure how much current this chip provides. So if we try the remote, so press the A button. Right, so I can see 2 LEDs flashing there. So there's this, the VT one is flashing very brightly, and I can see the one next to it is also flashing but less brightly. I think I might find another resistor for this one, so that, because that's quite distracting, the VT flashing so brightly. Right, so that looks a little bit better now. So now the A button, when I press it, I get that LED right next to VT. Which one is that? Let me have a look. So that's D3. So we've got D3, D2, D1, D0. So A corresponds to D3. If I press B, now that D0 lights up. So B is D0, and the VT seems to come on just to say that one of the outputs is on. So C is D1, D2, and D is pin D1. Let's see if we can hold multiple buttons. So if we hold A and B, yeah, so that lights the 2 outputs at the same time. If I do C and D, so you can hold all the buttons at once. Hang on, that's my B's not working there. There we go. If I can get all the buttons pressed down at once, you get all the LEDs and VT as well. So that's quite a simple module to use. It's just got the 4 mapped bit outputs, and so it's got 4 bits of information which corresponds to the chip number. So the datasheet, which I'll link in below, there are several different versions of this chip. So there's different pin outs. There's latching and non-latching. So latching meaning, you know, when you press B and then the B output will come on and it will stay on until you send another B to to make it go low again. This is the non-latching version. So it's this chip is designated M4, which means it's M for momentary and 4 for 4 bits of information. So so I've got 4 momentary outputs that you can use to connect to things. Now, of course, one of the disadvantages of such a simple device is they're not coded at all. So if somebody else in the neighbourhood has the same remote control, then my outputs are going to get triggered by their remote. And there's also possibility of interference, because the 433 megahertz is quite a commonly used band, so it's used for doorbells, for example. So it's possible that a nearby doorbell might trigger this. In fact, I might try my doorbell in a moment. And also car keys. So if you've got a car remote, then those are often using 433 megahertz. So those kind of signals might interfere with this setup as well. But it's very inexpensive, and if it's something not that critical, if it goes off by accident, then this is a pretty good solution, I think.